Hi, in today's video, we shall provide a short introduction on what exactly is the p-value for an hypothesis testing and how we are going to calculate it. The definition of a p-value for a null hypothesis test is quoted from Wikipedia as the probability of obtaining a test result at least as extreme or more extreme as the results that is actually observed, assuming that the null hypothesis is correct. To not complicate matters, we shall use a simple example to show how the p-value has been defined and how we're going to calculate it. And then, using this example, we see that by definition the ideas can be then extended on to other examples, and so let's begin. Now, let's say you have a null hypothesis being that the mean height of Singaporean guys is 170 cm. And the alternative hypothesis is that the mean height of Singaporean guys is larger than 170 cm. We also know that the height of guys follows a normal distribution with a standard deviation of 10 cm. And let's say for our example, we take a sample of 100 men and we got an average height of 180 cm. Then we go on to perform the hypothesis testing by calculating the Z or test statistic, assuming that the null hypothesis is true. And then we look at the definition of the p-value, which is over here. It wants us to calculate the probability of obtaining this test result, the 180 cm, that is at least extreme or more extreme than it. This means that the height is 180 cm, and so it is at least 10 cm greater than what the null hypothesis is saying. This means that the critical region, which is anything greater than 180 cm, is what we want to calculate the probability of. So we just need to find the probability that the height is larger than 180 cm given that h0 is true. And we can see this is the area under the graph of the normal distribution that we want. And by calculating that area, we get the probability over here, which is our p-value. We will calculate it out and we will already know that it is less than 5%, which is less than 0.05, which means that the test is significant and it provides strong evidence to reject the null hypothesis. So this is a rough idea on how you're going to calculate the p-value, and it should already give you an idea on what it means to be as extreme or more extreme than the results observed. But to reinforce our idea, let's give an example using a two-tilt test. So keeping the same null hypothesis, we change the alternative hypothesis to mean height of Singaporean guys not being 170. So it can be either less or it can be greater, just not being 170. All the steps of calculating the test statistics are the same because you only have one sample, so you can only take that sample 180 cm and use that to create your test statistic. But now, since the probability of being less than 170 by more than 10 cm, which means 160, is the same as the probability of being more than 170 cm by 10 cm, meaning the original one-tilt test, we need to double the probability that we calculated for using the test statistic. This is what it means when the definition says that the p-value needs to be a test result at least as extreme or more extreme. And since this is a two-tilt test, it could be extreme from the left tilt side or the right tail end. And so we need to double the probability we calculated, meaning this probability that we calculated using the test statistic, it implies that the p-value must equals to 2 times the probability of this original test statistic probability that we calculated. And the reason why we can do a double is because the probability that it is less than 160 will always be equal to the probability that is greater than 180 due to symmetry. So this is how you're going to calculate the p-value for a hypothesis testing for using a normal distribution. And these ideas can be all generalized to higher examples. It's just whether this will remain a 2 or not. You just need to calculate it correctly. Hope this helped clarify your doubts. Please like, share and subscribe and comment on anything you wish to clarify in the comment sections down below. Thank you.